Hey guys, I wanted to give you a run through of calculating stairs. This is just a straight run of stairs with no headroom restrictions or any run restrictions or anything. So just a straight run of stairs. The thing that's different in this example is that we are calculating our rise from the floor to the underside of the ceiling, and we are including our upper construction, which is just our floor construction and all the finishes. We have to include all the finishes. So here we have our ceiling. We have our 2x12 floor joist, 3/4 inch subfloor, and 3/4 inch finished flooring. The reason why we have to include even our ceiling finishes here is because we're measuring to the finished ceiling. When we are measuring our total rise, we do need to take it right to the top of the finished floor and to the finished floor. So if this floor ended up getting built up, we would actually have to measure from the finished floor to the finished floor. So our total rise here, we have 8'1" to the underside of the ceiling plus 13 1/4. That gives us an answer of 110 1/4. Okay, keep it in inches at this stage. We want everything in inches because all of our units and everything are all going to end up being in inches. So we have 110 1/4, and in order to figure out the number of risers, what we'll do is we'll take 110 1/4 and we'll divide it by our magic number, which is 7. So 7 is our rough estimate here. You could use 7 1/4, 7 3/8, 7 1/2. It's basically what you're aiming for a rise. We know that between 7 and 8 is a comfortable rise. So we're going to pick 7 here just to get a ballpark it. And we get an answer of 15.75. Okay, so this is units. Now in every case, guys, what we're going to want to do is keep that number and round down. So let's get rid of that 0.75 and just stick with the 15. So the number of risers we have is 15, okay? For our unit rise, which is the height of each step, basically, what we want to do is take the number of risers and then divide that from our total rise. So this was a ballpark, but you could see that because we have a decimal here, there's going to be some change. Well, I can't have a different height step. I can't have 0.75 of a step. So I have to put all that change and spread it out over every single step so that we end up with an equal rise and run. Remember that the difference between step to step cannot change by more than 1/4 inch for the entire set of stairs. So here we're going to take our total rise again, 110 1/4, and we're going to divide it by 15 this time. And that's going to give us an answer of 7.35 inches, which for our purposes, we can just simply round it to 7 3/8. 7 3/8 is 7.375. It's close enough for our purposes here because it's going to be, a 32nd of an inch off or something. So we can deal with that. So 7 3/8. Now, to figure out the number of treads, which is the part that you step on, it's pretty simple. Because you could see we have a rise here. So here's a rise and here's a rise. We have one extra rise basically. If you counted this out, we have one extra rise without a run. So all we need to do in this step is just go our number of risers, which is 15, minus 1 equals 14. Okay, if we didn't subtract 1, we would basically have a set of stairs where the top step of our stairs was right at the very top, flush with our landing. You may want to do that in order to increase the size of your landing, but in most cases we're trying to shorten how long the total run of the stairs are, so we end up subtracting one run to get that first step to be a step down. Okay, so our unit of run, what we have is our preferred stair formula. So what we're aiming for is somewhere between 17 inches and 18 inches for our rise plus our run. So rise plus run equals between 17 and 18 inches. So for this purpose, we're just going to go, okay, let's pick straight down the middle. Let's just go 17 1/2, so 17.5. And we're going to then subtract our unit rise from that. So minus In this case, I'm going to go 375 because we've picked 17 3/8. This is going to be harder to do on the measuring tape, so minus 7.375, which is 7 3/8, and we get an answer of 10 1/8. Okay, so every single run, not including the nosing, every single run is 10 1/8. So again, that does not include the projection of that little round over nose. That's going to just be our unit run is 10 1/8. So to figure out our total run, that's pretty easy. We have 14 runs and we have the size of that. So we just need to go 14 times 10.125 inches equals 141 3/4. Okay, so 141 3/4 will be from the face here to our last riser. Okay, that is important to note because if there happened to be a wall at the end here or anything else, if we had to worry about headroom, all of those things come into play. So as we progress through this year, we're going to get more and more complicated with these stairs, and total run is going to be something that we need to know. And if you were building a deck, for example, we would want to know where the stairs would land. So telling us total run might tell you where to put your patio stones so that your stringers aren't sitting right in the dirt. They're sitting on, some concrete or some patio stones or something. Now, the total line length of the stringer is so that you can order your stringer material, right? Normally we're using 2x12. Am I going to get a 12 foot, a 14 foot, 16 foot? Maybe I need to get a custom order, like a 20 foot 2x12 or something. We want to know that ahead of time if possible. So the total length of stringer, you might be thinking we could just do a big triangle, right? We have our big unit triangle. We have our total rise and our total run. We can do that. If we were to do a huge triangle from the ground to the top, what we would end up with is a triangle that looks like this. It would go like this, and it actually would come down to here. All right. I cannot dismiss that. Okay. And so it would actually not be the correct length of the stringer. It would actually stop here at our total run because you're going to use your total run number. So you can see that the angle doesn't work out. When we actually calculate it, it's actually going to come out to here. Okay. Yes, there's going to be waste with our stringer, but in order for you to get the full size cut here at the bottom and everything at the top, we'll need to do something a little bit different. So what we are going to do is we're going to get a unit triangle. So you might remember this a little bit with roofing, okay, and it's kind of similar, but we'll take a unit triangle and we'll figure out the hypotenuse. So we have 10 1/8, and we have 7 3/8, okay, and we'll figure out the hypotenuse there. So if you remember our fancy hypotenuse formula, a squared plus b squared equals c squared. Okay, so 7 3/8 squared plus 10 1/8 squared equals c squared, and then remember you have to square root your answer. And so for our hypotenuse here, we're going to get an answer of 12.53 inches. That's rounded already, 12.53. And you'll notice when you're calculating stairs, your answer is often in the 12-inch range. So somewhere between 12 and 13-ish. So 12.53 inches, okay? And then what we do is take that, so 12.53 inches times our number of risers, okay? Not our number of our treads, because that takes us to here. Our number of risers will take us the full distance. So times 15, and I'm going to run out of space here, guys, but so I'll just write the answer over here. Equals stringer. So our total length of our stringer, and I didn't pre-calculate this, so give me a second, 12.53 times 15. 187.95. 187.95 inches. Okay, I'm going to divide that by 12. Equals 15.66 feet, which is about 15 foot 8. So I can't get a 15 foot 8, but I can get a 16 foot 2 by 12. So that's the material I need to order, is a 16 footer, which kind of makes sense. That's quite a bit of rise, right? Our total rise is over 9 feet here, so that's going to be quite a bit. Now the angle of incline is actually the angle of the stairs. So think of your stairs like a rafter, and the reason why we want to know our angle of incline is for a couple things, but it does help us with our balusters, so our railings. All of, like, if you have a newel post here at the bottom and you're cutting your baluster into your newel post, that angle will be your angle of incline. Or so your bottom rail, I should say, not balusters. Your balusters are the little small posts here, and all the angles on your balusters, top and bottom, will be the same as your angle of incline. So knowing your angle of incline just kind of helps us with all of our finishing details and things like that. And this is something you probably haven't done too much, but we have to use our sine, cos, and tan. So if I draw my triangle here, okay, and I have my 7 3/8, and I have my 10 1/8, okay, we are going to use one of the sine, cos, tan to figure this out. So what I like to do is put myself, all right, in the perspective of the angle. I am this angle, which is the same as this angle. It's just a mirror image of it. So looking this way, which side is opposite of me? This side is opposite, and this side is adjacent, and this side has to be the hypotenuse always. Now, if I were standing over here looking this way, the 10 1/8 would be my opposite side, and the 7 3/8 would be my adjacent side. But since we're looking at this angle of incline, this is my opposite, this is my adjacent. So the way that this works is, in that formula, we have tan, which is opposite, the formula for opposite over adjacent. Tan of the angle, which is what we're looking for, is equal to opposite over adjacent. Sorry guys, I'm running out of room here. So now we have 7 3/8 over 10 1/8. Okay, and then what we'll end up having to do, so if you go 7 3/8, 7.375 divided by 10 1/8, which is 10.125, okay, you're going to get a decimal 0.72, and I'll write that down, 0.7284, let's say. There's a bunch of decimals there. You can round it to 2 decimal places. I usually just leave it in the calculator for this next step. And then what you're going to do is hit the second function on your calculator. So I'll write it here at the top. It looks like this, second. And then you're going to hit second tan, and your second tan will look like this, tan minus 1, okay, on your calculator. So with this number, again, you can just leave it as the 20 decimal places that it actually is. You don't have to retype it. Hit second tan, and you'll get an angle of incline of 36.0694, which we could just simply round to 36 degrees. Okay. Yeah, with angles, if you are a quarter of a degree off, you won't really be able to set that on any saws. Even if you turn your if you have a fancy miter saw or anything, a quarter of a degree is going to be very minor, especially if you're talking about 1.5-inch material like your balusters. Typically, or maybe even smaller, a quarter of a degree over 1.5 inches is very, very, very small. So we could just round that within 1/2 degree. So round up or down if you're within 1/2 degree. All right, guys, I hope that helps. Of course, we're going to do tons more practice, and making sure that we are following all the steps. So every time we do this, we're always going to follow the same exact steps. And then as things get more complicated, then we will have maybe steps in between, or we'll alter our steps. So as we get better at this, we'll start to be able to determine which information we can change, right? For example, like, do we subtract a tread, or do we want our landing to be flush at the top here? So there's things that we can change along the way, but this is the basic calculation for stairs.